I'm going to talk about novel manufacturing practices which are enabled by the new cutting edge machine tools and the new tool designs. Just to start up with a brief introduction, transfer line special machines have been the order of the last few decades, where people have been using these machines to process the different parts, but they don't offer the flexibility. So these days, of course, these machines are being replaced by CNC machines. The advantages of the machine tool has enabled, to consolidate various operations into CNC machines. What CNC machine offers is, first of all, faster cycle time. It eliminates bottleneck because CNC machine can process all the components, various operations together, unlike transfer or special purpose machines. And you can get higher part accuracy. The reason is you don't have to unclamp the part, move it on to the next machine, reclamp again to the next machine. You can process it on one setup, hence the accuracy is much better. There is no stack up of tolerance. And finally, there is reduction in training costs because it's no longer a special dedicated machine where the operator has to learn this machine, then the next machine. You just train one particular machine set and he will understand all the machining operations. So the obvious question is, how far you can take the CNC machine tool? Is there a limit? My answer to that is no. There is no limit. All you can say is sky is the limit. So let me talk about some of the strategies which I'm going to explain today. Of course, last year was a pretty tough year, and during that time all of you must have thought about how to make our operations lean, how to make it more profitable. So the CNC machines, if you tool them correctly, use right strategies, you can do wide variety of things. Starting with spinning tool. It's a special tool which spins and you can use it for turning, and it is a lot more faster. You can use it to cut complex metals which are like for which like Inconel, stainless steel, hard to cut metals. Then there is grind hardening. We are actually going to case harden it on the machine, and we can achieve hardness up to 60 Rockwell and depth of up to 2 millimeter. Then it's a pinch turning. Here I'm going to talk about an application for aerospace, machining blades. Hydro gauge, it's a in-machine based gauging process which is really very inexpensive. And then I'm going to give a few sort of a flavor about intelligent motion tools, and I'm going to pick a special application for machining differential cases and how we have used a closed loop feedback system to improve the tool design further. So I will start with the first strategy, which is spinning tool, and what we like to call this is think outside the box, because it's not a conventional way to turn the part. If you can look at the video over here, the tool is it's like a button insert and it's spinning. So it's a turning tool that spins and which you're going to use for turning application. Because of the setup, you can see the tool is going to be loaded axially. So all the cutting force will be directed through the structure. The machines are designed to handle the cutting forces a lot better when the forces are in axial direction. And what's happening is, since the tool is rotating, you can see that not a single point is in contact. It's like a multi-cutting tool insert. So you can get better tool life and better reduced wear as compared to a standard cutting tool. I have a slow-mo video of the spinning tool. As you can see, I have slowed it down almost. We run this at 2000 RPM. This is almost, you can see actual RPM. The part is rotating, the insert is rotating also. So what is happening is, since the point of contact keeps on rotating, the heat generated is not trapped into the part. As the insert rotates, it gets time to cool. So, and when it engages, it's again unheated, and it can take the cut as if it hasn't worn out. So because since it is rotating, the wear is uniform, so you definitely can get better tool life and improved productivity, because you can feed this particular tool almost twice or thrice the normal cutting turning tool insert. And another advantage is you can cut it dry. Now you don't have to worry about the coolant and all the excess moisture or coolant mist flying around. And what the unique tool design allows us is to reduce the chatter and vibration. The next application is really interesting. We are talking about case hardening on a machine. If you know grinding, you might think that burning a part is bad. Well, it is bad because you want to grind it, but if you want to case harden it, it's really good. So universities over the last 3-4 years have come up with a process where you actually just purposely reverse the grinding, typical standard grinding process. So what you do is, in grinding you don't want to induce heat into the part, you want to take it away from the part. But here you are trying to induce heat into the part purposely so that you can harden the part. So what we do is we purposely dress the wheel dull so that it can build up a heat. And then using plunge or traverse grinding, we can induce the heat into the part. What we do to quench the part is use the coolant. And we have an application where we can program the coolant nozzle so we can direct it properly to achieve a right balance in quenching. What we have done over the past years is we have also generated some new ideas, one of them being a tempering pass. We can also temper the material, because what happens is when you are grind hardening, sometimes the material gets brittle because of the untempered mat inside, so you have to temper it. Typically in a furnace, what you would do is you will pull out the part from the furnace, keep it outside for a while, and again put it back for tempering. But here what we do is we have established a sequence whereby we can do the tempering in machine itself. We have been able to achieve a Rockwell hardness of about 53 to 60, and the depth is about 1 millimeter to 2 millimeter deep. Of course, grind hardening is material specific, and if I can specifically say, it's based on carbon concentration. And what's more, it's ecologically friendly. Now, of course, if you have a volume of thousands of pieces and a furnace is justifiable, that's the way to go. But if you have a small application where you are running 15, 20, 25 pieces daily, you don't want to heat up the furnace, because the furnace is going to consume a lot of electricity and it's going to increase the pollution, and so it's not environmentally friendly. But grind hardening, it has got a very low carbon footprint. These are the samples which we have grind hardened, and the grind hardening, of course, as I mentioned before, it depends upon the workpiece concentration, the depth of the cut, RPM of the wheel, and the coolant direction, pressure and volume. Again, this particular demo is running at our booth on NT 4200. You can actually see how the part looks. The next one I'm going to talk about gauging, and it's an very inexpensive and yet automated gauging process. You must have heard, of course, about air gauging. In case of air gauging, you are using air to gauge the OD/ID. What we are doing over here is we are using high pressure coolant, and using the same principle as air gauge, we are gauging the part, gauging the ID and OD of the part using high pressure coolant, which is typically running at 1000 psi. So what it is, since it's resting on the machine, you don't have to buy a fully automated gauging system, because that tends to be expensive and it could run in thousands of dollars. This particular system can have a resolution up to 4 microns and repeatability up to 2 microns, and you can integrate it with the tool management system, so you can have a closed loop feedback. This is a video of the high pressure gauging system.
So the jump shot comes over, the coolant starts. Now
So you are gauging it right now. It gauges, you get a closed loop feedback to the CNC control, and that's about it. So it's as simple as that and as quick as that, and you can measure it inside the machine. The next process or next few processes are going to talk about how we can improve the cutting speed and improve the productivity. Starting with an aerospace application. Of course, aerospace, you're not talking about millions of parts, you're mostly talking about thousands of parts, yet blade is one such component where you need lots of it and the volume is really high. So we have come up with an interesting process, what we call as pinch milling, and what we are doing is it's a mill turn machine. The upper spindle and the lower spindle is working in tandem, and you are able to rough and semi-finish at the same time. And this particular example is a propeller blade example. So as you can see, both the spindles, the upper one and the lower one, are synchronized, and you can generate the machining process very fast as compared to the previous conventional one, where you will take a roughing pass, then come up with a conventional pass. This particular process is what we call as a smart intelligent tool. Where do you typically use motion tools? Well, the motion tools are mostly used for complex machining complex shapes, trying to machine hard to reach areas, and especially where you want to avoid purchasing special purpose machine, because of course those are expensive. In case of motion tool, the basic principle is you use relative motion between two objects to generate the motion. However, currently the motion tools in the industry don't offer a closed loop feedback. What I mean by that is, once you actuate the tool, you really don't know whether it's actuated or not. And what happens is you end up either damaging the part or damaging the tool. But we have taken it one step further, and I'm going to illustrate it with an example of a differential case. If you know differential case, there is a spherical seat which needs to be machined inside, and either you can use drop-in tools, but in some cases the cavity, the opening in the differential case doesn't allow you to actually go inside the part to machine the spherical seat. So there is only one way to process it, using motion tool, which can flip open. Here what is happening is there is always a drawbar in case of a motion tool which needs to be actuated in order to open the tool, or to have a required cutting sequence. In this particular case, we are using a tailstock on a standard 2-axis lathe to actuate the tool. By doing this, what can happen is, since this is a digital tailstock, we can program it to reach certain distance so that it can actuate it, and after that we can retract so that the tool disengages and goes back into the tool holder assembly, because as you can see, it has the knife edge has to flip open all the way to cut the spherical seat. And over here we are trying to machine the back face in case of the differential case. Both these features are really hard to machine in differential cases. Through this particular example, you can see that you can really take the CNC machine tools to a next level. All you have to do is design it correctly and use some creativity. In summary, what I would like to say is there are many creative ways to generate new processes. Of course, unique advantages of each process is spinning tool allows you higher productivity. Grind hardening will allow you to case harden most carbon-based materials. Hydro gauge offers a really inexpensive way to gauge the part in the machine. Pinch milling offers to improve the productivity, and a closed loop motion tool helps the reliability of the process. So with that, truly I would like to say sky is the limit, and you can even take it a step further.